Good afternoon, New York, and the rest of our listeners around the globe. My name is June Stoyer, and I'm the host of the Clean Energy View radio show, which is a special series focused on the world of clean energy. Our podcasts are available on iTunes under the Organic View Radio Network, or you can simply visit cleanenergyview.com. If you have a question, please send me a tweet at June Stoyer or post a comment on our page at facebook.com/cleanenergyview. If you'd like to be on the show or would like to find out about sponsorship opportunities, please contact us at info@cleanenergyview.com. Today's show is sponsored by ramvpn.com, the leading provider of next-generation online anonymity and VPN security solutions. Their architecture is unique, tamper-safe, and 100% guaranteed. They even accept Bitcoin. For more information, please visit their website at www.ramvpn.com. In the United States, we have enjoyed the luxury of consistent energy flow. However, mass power loss is something many parts of the world experience on a regular basis. Storms like Hurricane Katrina and Hurricane Sandy really emphasized our need to focus on the future of energy. Energy remains a global issue and one that calls for innovation as well as collaboration. IDA 2015 is an international forum shaping the next generation of energy for cities, bringing together experienced global industry leaders from across North America, Europe, Asia, and the Middle East to discuss and debate the state and the future of energy. On today's show, Mr. Robert Thornton, President and Chief Executive Officer of the International District Energy Association, is going to talk about their upcoming annual conference and trade show. So I'd like to welcome to the show Mr. Rob Thornton. Good afternoon, sir, and welcome to the show.
Hello, June. Thanks so much for having me.
Rob, could you share a little bit about yourself with our listeners and how you got involved with energy?
Sure. The organization I had, International District Energy Association, was actually formed in 1909. We're now in our 106th year. I've been in the district energy field for 28 years. I started in energy. I was a college student at Tufts University outside of Boston, and I wanted to work in the city for the summer. So I went to the financial aid office and said, hey, do you have any internships? I'd like to work in the city. They said, well, here, why don't you go to the Energy Policy Information Center, which was a Ford Foundation nonprofit on Beacon Hill in the state, near the State House. So I show up, bright-eyed and bushy-tailed. Hi, I'm from Tufts. They sent me to do research. They said, all right, kid, why don't you do the greenhouse effect? Now, I didn't really know what the greenhouse effect was. This was 1978. Energy was the moral equivalent of war. Jimmy Carter was telling the nation to put on a sweater, and we were dealing with the second oil embargo. It was really a very tumultuous time, but in looking at the greenhouse effect, what's now known as climate change, global warming, I saw that there was really some big challenge, both in terms of the environmental impact of how much energy we consume and our use of fossil fuels, but moreover that there was really a need for better energy policy in the United States. It wasn't so much the technology, it was really kind of the rules that that we're kind of governed by. And that was really the beginning. I basically had an epiphany that this was an important thing. Maybe I could make a living at this and make a difference too. And so I've been in energy since 1981 when I graduated, in solar, geothermal, but in district energy now since 1987. I started working in the field in Hartford, Connecticut, which was the world's first downtown district heating and cooling system. Began operations in 1962, supplying chilled water to air condition all the buildings in downtown Hartford, or the majority of the buildings. And that segment of our industry has really been booming over the last 30 years. District cooling has been a large growth area, not only here in North America, but around the world, and particularly in the Middle East, in the cities of Abu Dhabi and Dubai, where they don't really have an extensive electricity grid, although it's growing. They've built large district cooling networks to supply air conditioning to all that built environment that's really just sort of blossomed in the last decade. And it's fundamentally more efficient, uses less energy, and in the Middle East also reduces water use. These are all kind of common challenges facing cities today: energy efficiency, sustainability. But June, as we were talking earlier, you mentioned Superstorm Sandy. It happened in October 2012 here in the Northeast. I'm outside of Boston. You're in New York. Sandy was a galvanizing event. There were 8.1 million people without power in 23 states. It was a huge storm, but I think it demonstrated really sort of the strength of Mother Nature, but also the weakness of our energy infrastructure. We've become so dependent on reliable power and heat and cooling. When you don't have it, not only are people's lives at risk, but the economy really does stop. Here in the Northeast, the recognition of the need for not only new investment in more robust infrastructure, but a better model, a kind of a new energy paradigm is needed, particularly in cities. Cities like New York and Boston and, any large city. Cities are the economic engine for the region, and as a result, they really need not only reliable energy, power, heating, and cooling, but also it's got to be resilient. The economy has to be able to restore and respond and get back to business quickly. And it's as much safety as much, business continuity and impact on the economy. The huge losses resulted from the Sandy storm. So our conference here in Boston coming up end of June, IDA 2015, Inspiring the Next Generation, is really a double entendre. It's one, we want to inspire the next generation of energy for cities, working with groups like the United Nations, the C40 cities, the Urban Sustainability Directors Network, the U.S. EPA, Department of Energy, really kind of converging and convening all of those assets, but also inspiring the next generation of people. We want for district energy to be, I think, better appreciated, better known, so that young people can see, like I saw in 1978, there's a pathway here. There's a place to make a difference. I'm seeing every day young people first of all, they want to move into cities. They really want to consume what a city has to offer culturally, physically, intellectually. But they're also recognizing that, cities need to be more sustainable, and they want to participate in that. And so we're looking to have this conference as a means to introduce young people to our industry and help them identify career paths here.
I'm just curious, how efficient are we in the United States as it pertains to energy, and exactly how much energy do we waste as a nation?
We have a lot of room for improvement. A typical central station power plant, a coal or fossil-fired power plant, on average in the U.S. operates at an efficiency of about 32%. So, in other words, 2/3 of the fuel that goes into the plant is really wasted. It's not converted into useful energy. In fact, if you looked at the total electric power industry in the U.S., the waste heat produced by our power plants is equal to the total energy consumed by every nation on the planet, aside from three. Those three are the U.S., China, and Russia. Our power plant industry actually wastes more energy than all those other countries consume annually. So I could show you, if I could show you this on a chart, it'd be stark. I just showed it to a conference in Vancouver last week, and people were like, wow, I didn't realize, that is kind of the state of our electricity industry. Now, that's where we are today. No, the problem has been that's where we've been for the last 50 years. We've not really made progress in making our electric power plants more efficient. Now, we are seeing movement very much towards wind and solar, lower carbon solutions, and there are tremendous advantages of renewable resources, but we still have an intermittency challenge that we need to deal with solar and wind. A district energy combined heat and power plant can operate at a fuel efficiency of 70, 80, even 90%. 90% of the fuel that goes in comes out as useful energy in the form of heat and power. We use the heat. We don't dump it into rivers, lakes, oceans. We put it in a piping network. In Copenhagen, for instance, 98% of the buildings in Copenhagen do not have boilers. They're connected to a thermal grid, a heating network. And all across Denmark, they've invested in a heating transmission network. So much like we have high-tension power lines or, electricity grid, transmission grid, and then a lower distribution grid, they have the same thing in Denmark, but they distribute the heat. And the heat is waste heat from power plants. It's also heat produced by waste-to-energy plants. So instead of going to landfill, they convert their trash. It's all well sorted, and a lot of recycling happens, but they convert it into energy, useful energy, and they use that to heat their cities. In central Copenhagen, the downtown business district, they've also built recently a district cooling network. So even in places at high latitudes, commercial office buildings require cooling almost 12 months a year, because much like a human body, they're always generating heat from lights, people, computers, and just sort of internal density. So cooling even is occurring in our Scandinavian countries, cities like Copenhagen, Helsinki, Stockholm has had a district cooling system for quite some time. But to your question, there's huge room for improvement. And in fact, the EPA Clean Power Plan, it isn't so much about just cleaning up the grid, although that's one of the major objectives. It really creates an efficiency incentive for power plants, so that instead of wasting two-thirds of the fuel, there's an incentive for them to invest to be more efficient. And one solution is combined heat and power. Use the heat. There are a myriad of solutions, but we think particularly in cities and also college campuses all across the United States, North America, most larger universities have a district energy system. There's a central plant and an underground network of pipes that distribute steam or hot water for heating and chilled water, supply and return, for air conditioning. Our universities are really world leaders here in the U.S. in terms of investing in highly efficient, low-carbon, sustainable, and resilient energy systems. And the reason for that, June, is that many of our college campuses process millions, if not tens of millions of dollars worth of research every year. They're doing, cancer research and medical research and, even climate research at Princeton. And they need then highly reliable energy, not just lights, not just electricity, but also heating, humidification, cooling, of course. So our campuses have become, I think, really a proving ground for highly efficient, resilient, and sustainable energy. But primarily the investment has been driven by economics, efficiency, and also reliability. That's our strong suit in the district energy industry.
Is there an energy storage component that is built into the different types of energy, or energy technology, rather?
Sure. Many of our systems have chilled water storage tanks. At Princeton University, for instance, they have a gas turbine. They make power, or they buy power from the grid. And they also have steam-driven chillers and electric-driven chillers. So what they'll do is they'll make chilled water at night when equipment runs more efficiently because it's lower temperature, but also the price of power is lower at night. And then that chilled water tank, it's a few million gallons, is used during the day, particularly in the hot summer months of August, in the afternoon when the price of power can be 100 times, at least 10 times, but sometimes 100 times what the average annual rate is. The price of peak power can be significant. So a chilled water storage tank is essentially a battery, and what you're doing is you're avoiding purchasing electricity because now you're distributing chilled water. In most buildings, air conditioning is at least half of the demand. In places like the Middle East, 70% of all the electricity produced is used for air conditioning. That's, when it's August and it's 100 degrees outside and very humid, that's when you have the conditions for brownouts. It's mostly driven by a need for cooling. And so in North America, most of our storage is on chilled water and avoiding peak power. In Scandinavia, Europe, Germany, they also store heat. And in Denmark, and in some of the innovative cities there or communities there, they'll actually produce heat during the summer with solar panels, store it in large underground pits or aquifers, and then even use that seasonal storage during the cold winter months. So storage is a tool, a technology that you can use to strengthen the economics of your operating assets and shift demand away from, kind of expensive time of day or seasonal peaks. And I guess the other point, June, it's important to understand, one of the attributes of a district energy system, we're serving dozens, hundreds, in some, in Manhattan, the Con Edison steam system serves 1,800 buildings. Nearly 60% of that steam is recovered heat from generating electricity. So it's really co-generated or combined heat and power. That heat would otherwise be going into the rivers, but it's also displacing, downstream natural gas consumption. And in Manhattan, they use steam to drive the turbines to make air conditioning. I think there's like 400,000 tons of steam-driven air conditioning in downtown Manhattan. So the steam is really spinning the compressor, right? Just like a tea kettle, as opposed to an electric motor. That's avoiding about, 300 megawatts of peak demand on the grid. So the steam system, even though this may not, it's not obvious, the steam system is actually a very valuable demand avoidance asset in Manhattan. So
that's tremendous.
Yeah, it's kind of a hidden gem. But Manhattan has the largest district steam system in the world. Some larger heating systems in some other cities use hot water. In Korea, for instance, Seoul, South Korea, huge district heating network, growing 8% a year, annual revenue $3 billion, very significant asset. Paris has a huge district heating system, Moscow, St. Petersburg, but every major city in the U.S., Washington, D.C., Denver, San Francisco, Seattle, Boston, Philadelphia, district energy is actually quite ubiquitous, although often, not visible. So we used to be the best kept secret, I think, in the district energy industry, in the energy industry. But our star is rising. District energy is now, I think, on the radar screen of mayors as a result of Sandy, state and federal policymakers, as really out of the drive for efficiency, sustainability, and lower carbon. And we've been working lately with groups like the Urban Sustainability Directors Network and the C40 cities, and over the last year with the United Nations Environmental Program. I'd urge any of your listeners to Google the UNEP District Energy and Cities Initiative. They can find that right on our homepage of our website, www.districtenergy.org. But the UN District Energy and Cities Initiative was launched last September at the UN General Assembly, the climate summit that happened in September. I was there. We launched this initiative, and it's a great profile of 45 cities, across the globe, and how they're using district energy to reduce their energy spend, to dramatically cut their carbon emissions, and to make their economy and communities more resilient and sustainable. The UN has recognized, as have many mayors, large city mayors, you can't solve the problem just with electricity and gas. You have to look at the thermal requirements of your cities, because buildings can consume up to 60% of the total energy, in a community, and most of that is for heating and air conditioning. And that's an area now that our policymakers are starting to pay attention to. But the heat hasn't really been a focus for neither renewable policy or energy policy here in the U.S.
Yeah, I think that's an area that they definitely need to revisit. And the work that you're doing, Mr. Thornton, is tremendous. This event has such a tremendous opportunity for anyone who wants to learn from key players about what's going on, what the trends are, as well as what the obstacles are.
Yeah, so our conference, we're fortunate. This is our 106th annual conference, and we bring people from around the world, largely North America, though. We're based outside of Boston. We do a lot of work, across the country, and this conference is, in fact, hosted in Boston by Veolia. They operate the district steam and chill water systems that serve both downtown Boston and Cambridge. And Harvard University is also one of our active members, serve on our board. They're hosting, and they'll be providing a tour of their facility, their microgrid at the university. and the medical area total energy plant, which supplies steam, chilled water, and power to all the Harvard-affiliated hospitals in the Longwood medical area. They'll be doing a tour. And what's really interesting is the Kendall Station, which is, I don't know if you know Boston at all. It's right on the Charles River, actually on the Cambridge side, very close to MIT. For the past 40 or 50 years, that plant has been rejecting heat into the Charles River, like most plants. But Veolia in the last couple of years has invested about $112 million, not only in the plant, but also in a piping network. So the heat that was being dumped in the river is now actually going into a pipe and is being used to heat, buildings in Boston and Cambridge. So it dramatically improves the efficiency, lowers the heat rate, and makes this plant, environmentally a tremendous asset. The carbon emission reductions, I think, are in the neighborhood of 485,000 tons a year. That would be equivalent of 80,000 vehicles coming off the road. And the carbon reduction is actually the equivalent of about 600 football fields of photovoltaic.
Wow.
Wow. You can't afford 600 football fields in an urban setting. And so these types of systems deliver, real environmental benefit in a tight footprint. And we do it in an efficient, capital effective manner as well. But yes, so our conference is we'll be bringing people from I think you mentioned at the outset, Europe, Middle East, Asia. We'll guests from China and Japan, and people. We're doing a workshop in conjunction with the City of Boston with the Urban Sustainability Directors Network, and so these are the sustainability directors from cities who really have the task of decarbonizing, strengthening their grid, and the thing that they're interested in is combined heat and power, district energy, and microgrids, and the ability for where you have like a mission-critical business, whether it's a pharma factory, like a pharmaceutical manufacturer, like there is in Cambridge, a university, a teaching hospital, or even just your downtown business core. The mayors are realizing that they're now responsible for business continuity. They can't just say to their stakeholders, sorry, take the next 2 weeks off while we get the energy system back running. That Sandy wake-up call has, I think, really galvanized the focus. And the systems that stood up to Sandy, June, here in the Northeast were places like Princeton University. Co-op City in the Bronx has a 45-megawatt cogen plant right on campus, serves that community of 60,000 people. If Co-op City were a city, it would be the 11th largest city in the state of New York. And during Sandy, that unit maintained operations, kept all of the residents, it was October, warm and with lights. And they were backfeeding the Con Ed grid, helping to strengthen and restore operations. And so what we've seen since Sandy is mayors are saying, I want what Princeton has. I want an efficient, reliable, resilient energy system in my city, because the industry that is moving to my city, they're not just asking what's the price of power. They want to know how resilient, how clean, and where's it located. And so we're seeing now, and it's evident in New York State, the New York reforming the energy vision model, which is really a recognition that more distributed generation is a more reliable, durable, and I think functional model, moving away from the Central Station power plant 100 miles away, connected by a long wire, that's only operating at 32% efficiency. We need to move the generation closer to the load, improve the efficiency, get it in the 70s, 80s, even 90s are possible. We see it in our systems on campuses. And as a result, strengthen the local economy.
Well, I think everything that you're doing, especially with this conference, is going to help educate a lot of people and also get the conversation to continue and evolve to the point where we really need to go, especially when it comes to improving the existing infrastructure that we have.
Right. Yeah, the conference is IDA 2015, Inspiring the Next Generation. You can find it www.idea2015.org. It's on our website, districtenergy.org. But yes, we'll have a conversation with industry leaders, people that own and operate these systems. District energy is it's not easy. Making these investments in cities is not for the faint of heart, and these are robust, capital-intensive assets. But the challenge, June, isn't really it's not a technology challenge. This isn't there's obviously engineering challenges, but really, I think where we are, it's a policy issue, a regulatory issue. Mayors are saying, I want these assets available to me. I need to be able to tell, this hospital, this employer, that they can have resilient power available in the event of, the next Sandy, snowstorm, ice storm, whatever Mother Nature throws at us. But the conversation is really one of, okay, so how do we reform the regulatory? We have some, frankly, arcane regulatory conditions that I think really merit honest discussion, so that people can invest, cities can strengthen, we can decarbonize, and really get to the solutions that everyone wants to achieve. But it's going to require, I think, some collaboration, some concession, and a new model for how we incent and reward the people that build, own, and operate energy infrastructure. It desperately needs a revision, and that will be part of what we talk about. How can we, and it doesn't have to be a zero-sum game where one player wins and another one loses, but I think particularly as it relates to cities where we have both density and economic issue, these types of assets really do need, I think, a fair access to compete. And so we have the technology. It's a cliche, but and what we need, I think, is an honest conversation about enabling the investment to occur.
And to get over all the obstacles, it's something that I'm sure is not going to happen overnight, but it is definitely a process, and a necessary one at that. Mr. Thornton, thank you so much for coming on the show today. You are such an amazing person and have so much information, and I know especially for our listeners that are in high school and college, the issues that you're addressing today are very important for them, especially since their generation is basically the one that is going to be handling a lot of these issues that we don't fix as they currently stand. So, thank you for everything that you're doing.
Yeah, my pleasure, June. Thanks for making time. I really appreciate the forum. I would urge your young listeners to come to districtenergy.org, have a look. There's really a lot of information, a lot of good things are happening. I'd urge them to download the District Energy in Cities initiative from the UN Environmental Program. It's a great read. It'll be an eye-opener. And I think, maybe we'll have, the next Thomas Edison in our group that will sort of, move the needle on, on more robust, resilient energy for our cities. There's a huge opportunity, and we could use the enthusiasm and commitment. My own children are, my daughters are, college and out. They're moving into cities. They get it. They probably heard this conversation way too much at the dinner table, but no, I think to your young listeners, the solar and wind are great. We can incorporate those, but district energy and combined heat and power, it's really worth having a look. So, happy to help them navigate this sector too. Thanks again, June. Really appreciate you making time for me.
Oh, you're very welcome. And folks, please check out the companion article which will accompany this interview, which will be available at cleanenergyview.com with the information about the event as well as some of the other subjects that we've talked about today. Thanks for tuning in. This has been June Stoyer with the Clean Energy View radio show. Have a great afternoon, everyone.